there's no more questions on homework or anything, the next section is section 2.5, where we finally start to be able to really analyze stuff. So you guys came into this class knowing what average meant. And now you're in a stats class, a math class. You know that that's not the word we use. We use the word mean, right? Because, to be honest, average, I think I told you guys this, average could mean a lot of different things. So what we're going to explore today, what's the, let me see what you guys think. When you calculate a mean, what are you trying to get a feel for? It's a weird question, I know, but...
The middle?
Oh my God, it's like I planted you. The middle, kick ass, right? Sorry. So we're going to look at several different ways to try to measure what the center of data is, okay? Sometimes the average or the mean is the best measure of center. You're about to see your first full-fledged equation that uses some Greek letters in it. Yay! So can somebody tell me in English how to find the mean of a set of data?
You add and then divide by the class.
Kick ass. You basically just said the same thing. So you add them all up. So if I have a set of data, it doesn't matter. I'm just going to put some numbers down. Blah, blah, blah. Who cares? All right, you're no good. Oh, my markers are done. Okay. Add them all up. Ooh, look. And divide by how many of them are. We say this, the number of data points. Is that cool? Right? That's what you would tell somebody. You maybe wouldn't say data points, but you add up all the numbers and you divide how many there are, right? Math people, we don't like, I don't want to have to write this all the time. I want to create shorthand, which is all what functions are. That's all what equations are. It's just shorthand for something like this. So what's kind of like the official word for add, which actually ends up being the same number of letters? Sum, right? So it's like the official word for subtract is difference in product and quotient. So this is the sum of all the data points divided by the number of data points, right? So we decided to use the letter S because it's sum, but we use the letter S from Greek, and we use the capital letter S. So here's how I write sum. So that means add. So it's sort of like not done. So if I just write this symbol by itself in statistics, it doesn't mean anything. So very quickly, what is this? What's the square root of 9?
3.
All right, now do this one. You ready? Do this one. Ready? Do that one. Sorry. What's the problem? Why can't you tell me the answer? It's no freaking number. So it's the square root of what, Jeff, right? The square root of what, dude? Put something in there. I won't, too bad. So if I just see this by itself, it doesn't mean anything. I have to sum something up. Now help me out. How many possible, like let's say this question is, how many dogs do you have, right? 1, 3, 4, 5, whatever. So there's a whole range of possible answers somebody could give me. Somebody could actually run like a rescue and have like 30 dogs or something, right? So it's not like you can't go to infinity, but still, there's a lot of possible answers somebody could give me. In algebra, when there's a lot of possible values, how do we denote any of them without knowing which one it is? When I don't, I use X, right? So I want to add up all the data values, and how do I represent all the data values at once? X. So the data points are the values of the variable, which is the question, correct? So just like in algebra, for the variable I use X, here we use X. How are we doing? So this means add up all the data values, and then what letter do you think I want to use for the number? It's a funny math boy. The number of data points.
N?
No way. Okay. So that's our first little formula, and just like any mathematical symbol, it just replaces a phrase. Every mathematical symbol replaces like a phrase or a question. Why was the square root of 9 3, by the way?
3 times 3 is 1.
So what does the square root symbol actually ask you? What does it take? Yeah, what does it take 2 up to multiply by 9 is one way you could put it, correct? You guys with me? Isn't that what it means? So you've all internalized that. You don't even think that question directly necessarily, correct? You've internalized that. So you can translate that mathish into English without thinking about it. Because you've internalized it. You with me? This is some new shit. You're gonna see this a lot this semester, this symbol. So every time you see it, you're gonna have to go slow. It's just like when you're learning a language, German or something for the first time, you gotta go slow to kind of like go step by step. What did this mean? What did this mean, right? So for example, if that's the data, let me put this down here. That's the data. What is this? What is it? No, don't tell me what it means. What is it?
13.
All right, I like it. So it's 13, right? Cool. What would this be?
13 squared.
Good. I square the sum of x. You with me? So that would be 13 squared. Does anyone know?
169.
I love it. Now, here we go. We're going to see this symbol a lot, so I want to focus on it for just a minute. Why was this first question easy as hell? Because I know the x's. I just have to add them up. So what if I asked you, what's the sum of x squared? Do you see the difference between these two? This one says square the sum of x. That one says add up all the x squares. Do we have any x squares yet? No, so let's go make them. So we're going to see equations with a sum symbol in front of something. If you just cover the symbol, you go, oh, I got to make a bunch of those. How do I make a bunch of those?
1, 9, 16, 25.
So what is that?
25 times 25.
Well, you get 26 plus 25, right?
51.
51.
51. Is that cool? Is that all right? You guys okay? Let you let that soak in. So again, you all are cool with this. Nobody was looking at me quizzically, as you all are now. So why was this easy? I gave you the x's, didn't I? So the sum of the x's was easy. Before we wrote this, if I ask you that question, that's harder, because I don't know what the shit the x squares are. So then you just make them. I know the x's, so I know the x squares, and then you just have to add them up, right? So here, try this one. So what do I need a list of?
X minus 2.
No, I don't need a list of x's. I got a list of x's. What do I need a list of? Again,
Those.
I need to know what x minus 2. I need to know what those are. Let's make a list of those. Do you start to see what I'm saying? If you cover the sum symbol, you're like, oh, I need a bunch of those things. I know x, so I can make all the x minus 2's. And then I'll do what this tells me to do. I'll add all the suckers up.
5.
Let's see. What do I figure? Good. 1 minus 2, 3 minus 2, 4 minus 2, 5 minus 2.
5.
5. So that would be 5. Kick ass. Cool. Real quick, I can't help but say this. This has nothing to do with anything. Just go with me for a second. How many data points are there?
4.
4. I subtracted 2 4 times, correct? So I subtracted 8 total. 13 minus 8, 5, right? Okay, I'll stop. Like I said, nothing to do with anything, just a math thing. I had to get it out. Okay. Do you guys get a feel for that summation symbol now? It really is that simple. I'm gonna have to be given the data. A formula could say any of those things, and then I just make what I need and add them up and then put that in. So we're gonna get practice with that later. We're actually gonna develop another formula that's gonna be a little more than this. What's missing here still is the symbol for the mean. Because what does this equal? This equals the mean, but there is a symbol for the mean.
Why?
I like that, but no.
It's mu.
Yes, but which mean is that? There's two main means. I could either have a population, and it kind of makes sense. Anybody watch football ever? Even if you don't, Super Bowl, back in the day, Super Bowl 48, whatever, they would have the Roman numerals, and they would come down like in the graphics would have them in stone. Bro, Super Bowl XX. You guys kind of with me? The funny thing is, the Super Bowl 50 wasn't too long ago. Do you know the Roman numeral for 50?
No.
Yeah, so it would have been a big stone L, which would have been so beautiful, but they didn't do that. They just said 50. So I'm like, whatever, Super Bowl, whatever. So my point with all that, by the way, they wanted to make it like, yeah, we're the Super Bowl. We're not going to use our normal numbers. We're going to use Roman numerals. Yeah, so when I have a population, I very often use Greek letters to go, yeah, I got a whole population, right? This is population mean. And again, this is called mu, is the name of the letter. If I have a sample mean,
So,
yeah, X bar, same little formula, just a different symbol. So if somebody came along to me and said, I got X bar 7, I know they took a sample. They don't have to tell me, right? I know that seems a little weird, but do that. Okay. How you doing so far? So we're going to see another situation later where we have a Greek symbol for population something and a hour symbol for sample something. We're going to see that later today. Okay, so that's pretty straightforward. Now that was a lot more involved than you thought a discussion about taking a mean would be, yes? But again, this is our first little step with formulas, so I wanted to make a big deal out of it. Okay, so one way to measure the center of data is to take the average. Let me ask you guys, oh my gosh, that's weird. This is like too new. Has anyone ever looked at home prices in the area? Whenever you see anything, I can pull it up and I want to. Whenever you look at anything about home prices, they never tell you the average or the mean home price. Does anyone know what they talk about? Median. Okay, so let's talk about what that is. Let's say I'm about to start work at a company. Right, so one way is the mean. We're going to talk about the second. Let's say at this company there's three people that work, three employees and one CEO, right? And let's say one guy makes 38,000, somebody makes 40,000, somebody makes 42,000, and then we got the CEO, right? It's basically reality. If I took the average and then told that, let's say I'm going to start working at the company, and I want to know how much I can expect to make. And they take the average and they tell me the number. Can you guys, anybody really quickly, what's the average of those? This is my population, by the way, right? What's the average of those? 620, 155. Is that right?
155, you're correct.
Yes. So under 55,000, right? Is that an accurate representation for a new employee on what they can expect to make?
no.
No.
Shit, no, right? So the average does try to tell me the center, but its downfall is it takes into account all the values. So if I have, obviously, what's the big well, you just gave it away. This would be an outlier. So anytime my data has outliers, the mean is going to be biased in that direction. So a better measure is something we've already discussed. We just didn't give it its full name. What would Q2 be? What's Q2 also known as? That's Q1.
40.
2 quarters, 50 cents. Yeah. Just really quickly, what's P50? Yeah, half of 4 is 2. You have to average the second and third, so you get 41,000. Does that sound like a more representative number to give somebody who's just starting? Yes. And if the CEO suddenly said, I'm going to give myself a raise, right? Right? Does the mean change? Hell yeah. Does the median change? Nope. Doesn't care. The median is more about position instead of value, correct? It's just the number in the middle. It doesn't care what the actual values are. You guys see what I'm saying? So when you have outliers, you might want to use the median. So you'll see outliers. You'll see medians for home prices. You'll see medians for incomes, stuff like that. Okay, I like it. Blah, 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 blah. Okay, so this is now known as the median, and the symbol for the median is X. My joke is it looks like a sample mean that had a rough or a good night. His little hat got all messed up, right? So that's him. Okay. By the way, one way to remember this is what's in the middle of the road. Okay, there you go. So the middle of the data is the middle of the road. It's the median.
So median just equals Q2, that's it?
Median equals Q2, totally. Totally. In fact, I think we did look at the 5-number summary in the calculator. Remember we did one of our stats? Did we look at the 5-number summary? Do you guys are like
Yeah, we did.
every day before this.
Not
is
on the
over.
calculator.
Huh?
Not on the calculator.
We didn't do that in the
We did
calculator?
like we did a
We did, but it didn't show you how to get the 5-number summary in the calculator.
no.
Ooh, I'm
we
so
didn't get
mean.
that.
I'll show you today. I have to show you today because we'll do it. Don't worry. But in the calculator, it actually says, if I remember correctly, it says MED instead of Q2. So we'll see. Okay. So there are certain times the median is better than the mean, but in general, the mean wins. The mean is more often useful. Okay. So that's why you see it more often than you do median. Tell me this, what kind of data does mean and median work for? What's the two main types of data? Quantitative and qualitative. Sorry, that's the appropriate face. You're looking at some guy going, whoa. And she's back there like, sorry, I love that, that was awesome. That was the correct reaction, thank you. So far, this will only work with quantitative data, do you agree? I mean, if I have hair colors, I can't add up hair colors. If you think you can, show me, because you can't. And here, I can't find the median, because what did I do to find the median? I took the average of those two, for example, right? So there is a measure center that works for qualitative data. So what would that even mean? Let's say we go out to the parking lot, we just start writing down types of cars. The center of the data would be where the data seems to be clustering. It would be which type of car I see the most of. Does that make sense? So that type of center is just where does the data seem to be clustering. So it's the thing that occurs the most, and we call it the mode. I always think about pile of mode, where you want the one that's got the most, bless you. Anyway. So it works for qualitative data. It's whatever occurs the most. So if I go out there and I see 80 Fords and 20 Pintos, 20 whatever the shits, I don't know, then Ford might be the modal class. It might be the one that occurs the most. It obviously also works with numerical data. So for example there, what's the mode? 1. Unfortunately, this poor little guy doesn't get a symbol. One semester my class felt bad for it, and we made a symbol. We just call it capital M was the symbol, but it doesn't, it's good. It doesn't need a symbol. So the mode here would be 1. What about here? 1, 1, 2, 3, 3, 4. What's the mode? So does it have a single mode?
No.
It's got 2, so it's bimodal. Bimodal, 1 and 3. Is that cool? You can go up to trimodal, but beyond that, it's like, no, the data's not clustering anywhere. It's just, does that make sense? Up to 3 places, and then past that is like, nah, it's not really clustering anywhere. We give up. You guys all right? So you could have up to trimodal data. Okay. All right. And of course, like this data, what's the mode? Good, no mode. There you go, done. Nothing occurs the most, so there's no mode. I love it. Okay, so mean, median, mode are the 3 big ones. I'm gonna tell you one more. I guess I'll keep this up here. This is not, the book doesn't talk about this one. It's not outlawed or anything, don't get excited. Turn you into, let me turn my camera off and let's talk about this. Mid-range, what's the range again? High minus low. So the mid-range kind of makes sense. It should be the middle of the range. So that means I would take high and low and average them. The name tells you what the hell to do. The middle of the range. Take the high plus low and then divide by 2. That's the mid-range. Just another way to get an idea for the middle. And that kind of makes direct sense also. What's in the middle is basically what's in the middle of the most extreme. Bam! That's another way to figure out what the center is. Okay, you guys all doing all right? This isn't any too ground shaking. Now, got so much paper. Hold on. There it is. So I've got a handout. So, let's do this first. Anybody need to borrow a calculator? One of these has low battery, so if you have an ID or a phone or something. Okay, yeah, you're good. I used to be trusting and I can't do it. Yeah, you want me to borrow? Make sure there's battery though. One of these is low enough. Don't remember which one. Make sure it's got battery before you go too far away. Make sure it's got battery. Make sure it's got battery. Make sure it's got battery. Is it flashing red? Oh, you're good. You're good. One of them's flashing red. Okay. Look at all these cars are collected, man.
Nah, I'm not giving you my car key, that's for my house.
Oh, okay. So all I can do is.
I need my car key.
Crap, somebody put this together wrong. Everybody's good? Alright. So, what I really, really, really would love is if it's at all possible. Some of you guys are set up, some of you guys are set up beautifully for this. Make sure it's got battery. I need like, the really perfect group would be a group of 4. So, that one's dead. It's got a little red dots. Yeah, there you go. Now watch that one, see these ones. Okay, good. And you'll see when you get this sheet, it's best if you have 4 people. So, for example, you guys might want to fill those in. You see what I'm saying? Like you guys are good. If you just turn around, you got 4. Is that cool? Okay. You two might want to go over there because then you have 4 and 4. Or no, you don't. I can't count. I'll let you guys figure it out. It's best if you have 4 people in a group. So you can get up and move around if you want to. If you want to do more work, you can have less than 4 people in a group. All right. So the reason I changed Group D, I used to have Group D that was 6, 7, 8, 9. I changed it just to make number 3 a little more extreme. Would you say that each group? No. Does it agree with what you found? Not really. Almost everything's 13. So it kind of, just by looking at that, it seems like they all should be the same data, but we know they're not the same data. The work you did down here, I think you got 10801, right? Mm-hmm. And then what'd you get for the next? 12421. This was we call this uniform distribution. So if I say the word uniform, what do you guys think of? Closed that are all the same. So uniform is the same. So a uniform distribution is where everybody gets the same thing. So if I ask you a very strange question, if I look at the mean as home, which data set had more data values get further away from home?
D.
This one did. So we have a number that represents the middle. The number that won, there's a lot of measures in the center, but the number that most of the time we use is the mean. So that number represents the center. There's one more idea, that if I just figured out that number, that would be a way to summarize a set of data. So if I told somebody where the middle was and how spread out the data was, So if I have 10 million data points, but somebody just tells me what the mean is and how spread out it is, I have a pretty good idea about the data right there, just from those two freaking numbers. They summarize 10 million beautifully. Are you guys kind of following? So let's say this. Go with me for a second. You all are aware of a website called Rate My Professor?
Yes.
Okay. Quick story about that. When we heard about it on the East Coast, I was working at the college. The next day, you could tell a lot of my colleagues had rated themselves. They're all like, essence of the, I'll never forget this. One guy knew exactly what essence of the essence is what, whatever. There's another website that actually tells you the grade distributions for a professor. You actually have to pay money to get in it, but the funny thing is, that is public domain access knowledge. You could just call the college and ask for it. It's public knowledge, grade distributions of professors. So, let's say you have these two professors, you're trying to figure out which class to take. And the two professors have like almost the exact same Rate My Professor, the times work great, there's nothing like that. There's only one difference between them. They even have the same exact average. Let's say that they give, you look at the website I told you about grade distributions, and they both give exactly a 74.8 as an average, right? Their average final grade is a 74.8. What if I told you this professor, we'll call them Professor A. Let's say this professor actually has a range from, let's say like a range of like 20. They go by 20. So for anywhere from 54.8 to 94.8. Whereas this professor has a range of, what you got, Jeff? What you got, buddy? Let's say a range of 10. Also, one thing I forgot to mention, we're at a university, right? Because what's kind of failing here? What grade is failing here?
D.
A D, basically, right? Because it doesn't transfer and all that kind of stuff. When you're at university, a D is passing. Do you guys all know this? Don't think about that when you're going over a bridge and you're like, did this person make D's in all their classes? So D is passing in university. So knowing the middle, knowing the average grade wasn't good enough to differentiate between the two. If I know the spread of their grades, now I can determine which one to take. Now, does anyone have an opinion about which professor they would take?
B.
I love it. To me, it depends. If I know, and you might pick up bitterness because I've actually gone through this. If I know I'm going to kick this class's ass, I'm going to take the professor that actually gives A's. Yes? Because I have had this happen to me where the professor was waiting for some deity to come along, and then they would still just give them an A minus, right? Sorry, I got a B. And I was like, if I knew I was going to suck at this class,
B.
which one would I be tempted to take?
D.
The professor that doesn't seem to fail anybody, right? It seems like they give D's at the lowest. Are you with me? Now, kids in general, you don't want to do that shit, but I understand. So knowing the center of the data plus how spread out the data was, those two together give me a really good feel for what the data looks like. I don't have to look at all the damn data. I just need those two numbers. Are you guys semi with me? You're like, yeah, keep going. Okay. So now we're going to talk about what does the math look like to calculate this number, right? This number that's going to represent the spread of the data. Let me turn you off. All right, so I'm going to give us some data to work with.
It wasn't.
What happened?
It bled.
It did what?
It fell. It fell.
Oh, it fell over? Oh yeah, I just didn't have the tripod good. You think I know something about this thing. Okay.
You would have believed when we said nothing. Right?
So guys, let's say I have data set 1 and data set 2. This is exciting. So I got 1, 4, 4, 4, 7. 1, 2, 4, 6, 7. Okay. So 2 data sets. The ranges are the same, correct? Can somebody figure out the means for both of them? Yeah, they're both 4. Is that cool? The means are both 4. By the way, that symbol I just used, what's the symbol for? Population mean. So this is a population. I'm assuming it's a population. We all think of a population as a large group. It doesn't have to be. It just has to be the total group I want to say something about. These are what I want to say something about. That's my population. Okay, I like it. So now we're going to talk about, okay, so let's really nail down the definition of spread for statistics. Spread is how far from the mean do the data points get on average. Let me say that again. The idea of spread in statistics is how far from the mean do the data points get on average. Right, so it's basically another way to say it is the average distance from the mean to all the data points. Okay, I love it. By the way, something you're going to learn very quickly about me is I go through a lot of derivation. A lot of what we're going to do during derivation, you'll never have to actually do yourself. It's just derivation to get to a formula, and then we're just going to apply the formula, right? So we're going to do this a lot. Okay. So today we're going to actually see something you don't normally get to see. You're going to see a formula get created, and the really great thing is, if I know what I want a formula to do, I can make it do that, right? That sounds terrible. Too bad. Right? So I can create a formula that does what I want it to do. So what I want this formula to do is to figure this out. That's what I want to know. I want to know this. Now let me ask you a really silly question. If I wanted to know the average left shoe size of everybody in this room, what do I need a list of first? Shoe size, left shoe sizes. Yes? Are you with me? If I wanted to know the average age of everybody in this room, I need a list of, holy shit. If I want to know the average blank of everybody, I need to have a list of blank, right? So here I want to know the average distance from the mean to all data points, right? So what do I need a list of? I need a list of distances from the mean to each data point, correct? So then I can find the average of them. I really want you with me as to why the formula gets put together the way it does. So let me put this, let's do data set 1. I'm going to put it like this because this is a better way to have data. It looks more like our lists and our calculators.
Is that an X at the top?
That's an X, yes. Please don't tell me my X's don't look good anymore. That would really suck for me. What operation do I have to do to figure out how far apart two numbers are?
Subtract.
Subtract, okay. So X minus mu. Is that cool? That'll tell me how far data points are. Now, there's a little problem with this we're going to talk about in a second. So what was the mean again? 4. So 1 minus 4, 4 minus 4, 7 minus 4. Now, if I add those up and divide by how many there are, I'm going to get what? Yeah, I'm always going to get 0. Anytime you take all the data points, each one minus the mean, that list will add up to 0 every damn time. You'll have equal amounts negative, equal amounts positive, because that's what the mean's supposed to do. It's supposed to be in the middle of the values. So you're all like, good job, Jeff. You got us to a point where it's always 0. Yeah, good job. So there's two things we could do. What is the most direct thing I can do to a number to make it always positive? Well, hold on to square. That's a less direct way. Absolute value is a direct way. You with me? So if I just took the absolute value of all this stuff, the negative would go away. Does everybody understand right now the problem is the negative? And did anyone pick up on the fact that that's not really a distance? You would never say that you're negative 4 feet away from me, even if I turn around, right? Because negative 4 feet, you're like, in Quaid, right? That's weird. You can't be negative feet away from me. That's weird. So let's not talk about it. So absolute value is based on distance. That's why it's always positive, right? Okay. One major problem with absolute value. Does anyone know what it looks like as a graph? A V. So say we're in a plane. You ready? We're all in a plane. flying. Yay, we're gonna have a great time. Yay. And then all of a sudden, we bam! Right? Do you want to be on that plane? We are all dead. We are all against the wall, smooshed together, right? Very sorry to put that image in. Sorry. So I much rather would be, so I don't want to do that. And real quick, that I know that's a plane and all that stuff. What does it have to do mathematically? There's a lot of weird shit about this point right there. What's the slope here? Isn't the slope negative? Doesn't it instantaneously become positive? Math doesn't like that shit. We call this point a kink. Kind of like when you kink the hose. You ever done that? You kink the hose so the water doesn't come out? Some of you guys are enjoying that too. Okay. So I don't want this. There's many mathematical reasons why this is bad. So wouldn't I rather be in the plane that does this, and what of course does this? The thing you said earlier. What looks like this? Parabola. And where's the parabola come from? What equation? X squared. And obviously x squared would make this positive, right? Now, is everybody with me? There's a problem. I can't have negatives. You kind of understand a little bit maybe why absolute value is not a good option. So the best option next is square. If I'm squaring everything now, what do I have to do at the end? If these represent dogs, and I square this, isn't that square dogs? What happened to these square dogs, right? I don't want that. So at the end, I have to square root. Is that cool? Why are we squaring? To kill the negative. So at the end, I have to take a square root. So let's do this. So now I want to square all this. So that's easy enough, right? Okay. So now I can go back to what I was originally doing. I can add up all the square distances and divide by how many there are. That'll be an average square distance, and then I take a square root. How we doing? So anytime I want to take an average of something, I'm going to see what I'm about to write down. Yeah, go on. So what did we just say we want to do? We're going to add all these up, right? I want to add these up, divided by n, the number of data points, right? How many there are. If I see sum something up divided by n, that is the average this, correct? That's what I was saying earlier. Sum up the ages divided by n, average age. Sum up the shoe sizes divided by n, average shoe size, blah, blah, blah. So here I'm going to get an average distance from the mean squared is going to be the result of this. And then I take a square root, and then it's exactly the spread we want. Are you guys a little bit with me? How far away is each data point from the mean, and then kind of average those, right? Yes?
Wouldn't it be that divided by n minus 1, or am I getting...
No, you're getting ahead of me.
Okay.
This is a population. Just hold on to that. That's going to be a correction for if it's a sample. That's why I start with the population. Yeah. The symbol we use for this, not surprisingly, this is the idea of spread, correct? But the official name is standard deviation. Does that sound familiar to anybody?
Yeah.
If not, now it does. Standard deviation. And it kind of makes sense, because if a data point's different from the mean, didn't it deviate from the mean? No? What's deviate mean? Change from. So isn't a data point, if it's not the same as the mean, it's changed from the mean, so it's a deviation. So standard is sort of like, you think of it as a standardizing test, a standardizing thing. So taking the average is sort of another way to standardize something. So the standard deviation. How far away does every data point get on average? The symbol that I use, not surprisingly, again, that's a word that starts with S. We're going to use sigma, but we're going to use lowercase sigma. Uppercase sigma was the E, right? Looks like an E. Lowercase sigma, that's this dude. Lowercase sigma looks like a fat R. So it's all practice drawing it, right? Start at the belly, start like at the chin, belly, back up around to the cap. Wow! Right? Sometimes mine are skinny, sometimes mine are really fat. Just depends. Okay, maybe.
Do you have to do the X right after? Oh,
Say again?
do you have to do the X right after?
Yeah, you'll see on your
so-
calculator it's got a little X, and that's just because you could actually put two lists in, so you'll have a sigma X and a sigma Y, so you can tell which one it came from. But later we're going to see another thing there. We don't need that yet. So this would be, this isn't that yet, this is sigma squared, because I haven't taken a square root yet, right? We squared in the middle, we have to square at the end before we get the answer, so we stop for a minute. This symbol actually has a name. This is the variance. Right now, it just means we're not done. Later, we're going to talk about what else it means. So if I plug stuff in, what is the sum of these? So this entire damn thing is 18, correct? You cannot plug anything there. You can't. Because what does that mean? That means all the data points. You can't put them all in there at once. You replace the whole damn thing, because the sum of these is 18. So the entire thing is 18, right, guys? That's another deviation, sorry, from algebra, right? And then what's n? 5. So what do you get for the variance? 3.6. So then what do you get for the standard deviation? I appreciate that, but no.
1.897.
1.897. If it was square root of 0.36, you would have been right. Yeah. You guys, you still sort of. So what does this number represent? It represents the average distance that the data points got away from the middle. On average, how far did the data points get from the middle? Say again? 1.897, exactly. So this is our next official formula. That is the population variance, and this is the population standard deviation, Greek letter, right? So if it was a sample, we would just use the letter S. We would use our letter instead of the Greek letter. Bless you. Now, you guys, what I want you to do right now, first off, just tell me, without doing any work, should this have a bigger or smaller sigma? This data set. Should its sigma be bigger or smaller?
Bigger.
Why?
Data points different?
The range is the same for both, right? I know what you mean though, but the range is the same. Which data set gets further away from its middle? The second one, right? The first one's got 3 things that stayed at the middle. The second one's got only 1 thing, right? So which one is more spread away from its middle? The second data set. What's this measure? How spread away from the middle a data set is. So if I do all the same work, which you're going to do right now, do all the same work we just did for this data set, you already know this answer should be bigger than 1.897 because it's more spread out, and that's what this measures, right? This measures how spread out data is. So real quick example, when you guys take a quiz, I expect the standard deviation to be around 15. What that means is if the average is 75, on average, you guys got 15 data points away from 75. So some people got down, some people got up. Sometimes I'll have a standard deviation of 22, which is really big, which normally means somebody got like a 20 and somebody else got 105 because they did all the bonus points. I give you bonus questions on tests. You guys, so that would really make the standard deviation grow, wouldn't it? But a normal one would be about 15. I'm sorry, keep going. Now, do everything we just did. Do it for 1, 2, 4, 6, 7.
I have a question.
Yes.
So when you're doing sample, which one would be a capital S? Would it be
Which one would be a capital what now?
like, because you said if.
Oh yeah, this is capital sigma.
If it was a sample, right? We were taking.
No, okay. The capital sigma letter means sum. That's all it means. The lowercase sigma letter means standard deviation.
Okay.
And if it's squared, it means variance. Yeah. So it's not. So if it's a sample, then I'm going to use the letter S,
For which?
not a Greek letter. For instead of sigma, I'm going to use S.
Okay.
This always means sum. I'm going to leave that guy alone. Yeah.
Got it? I say, start with this, start with like, or start with like the list of all the exits.
The nice thing is not too much changes, right? There's only a couple data points that are different, so there's a lot of stuff that stays the same.
We got the square it to get rid of that negative. Yeah, this is the square root number.
Just make sure all of these are one thing I forgot to say. We'll see in a minute. Standard deviation always at least 3 decimal places.
It's a zero,
Oh, that's right. Just put a 0.
so I just put a zero.
So you said that formula is for the population of the sample, right?
Oh, add up those. Where are those? Aren't the X minus B scores there? Right? Isn't this list X minus B scores? Isn't that what that list is? Add them up. So that's where it's easy.
So we plug this into here, right?
Yeah, whatever the sum is.
Which is
26.
26, yeah. So this like it's
No,
just-
not that letter. This
Yeah.
whole thing, yeah, is 26, yeah.
Okay, but that's just there to show.
That means the sum of, and then this tells you which column to look at. Or which column to create if you haven't made it yet.
Oh, okay.
Yeah. Start catching up, you guys.
Wait, how did they get zero?
For the 4? Because you're doing 4 minus 4.
Oh, no. Because I guess they said that the last different answer was here. But I didn't get that.
Where?
Because I heard somebody just say, yeah, no, that they got zero.
26 is.
Okay, no, no, maybe I heard wrong, because that's what it was.
Sum of this shit, which is this.
When you're doing the, you know how you got the 4? That's when you're doing the square root. Are you just doing it negative? Are you doing just like. Because what I'm doing is I'm plugging the whole equation, but I don't know how to do that right.
Did you guys get this here?
So here you just plug in the sum, 26.
So, real quick.
Yeah. I know, I got confused with that too, but yeah, it's just a number, it's just a whole sum.
In general, standard deviation, I want you to round it at least 3 decimal places because I'll tell you a couple of things. Bless you. All the homework, the quizzes, and test 1, you're going to have to do standard deviation using a table like this. You with me? After test 1, we're going to take the standard deviation out of one var stats. So let's do 2 things with the calculator right now. And real quick, that's bigger than the other number, which is what we predicted, correct? So take your calculator. Oh man, wake back up. Put into list 1 the 5 numbers we're working with. 1, 2, 4, 6, 7. All right, so let me get it from the beginning. Get stat, edit, and then we're gonna put into list 1. If there's anything in list 1, just go highlight list 1 and hit clear. Let me know if there's any trouble.
Put 1 or 2, group 1 or 2 data set.
The one we're doing right now, 1, 2, 4, 6, 7.
Okay.
All right. So 2 things I want to show you. If I hit stat, calc, One var stats. Does anything look familiar? Oops, and then you have to do calculate. Some of you guys, by the way, depending on your calculator, either just says one var stats on your screen, hit enter because it defaults to list one, or you get this little thing, list one, no frequency list, calculate. So what looks familiar up there?
Wait, so after we press,
Oh, sorry.
after we make the list, what do we press?
Stat count.
So let's see. So you're in the list now, right?
Yeah.
Then hit stat, calc,
Oh, okay.
one var stats. Make sure it's list one. All right, what looks familiar up there? X bar is 4, right? That's what we got.
Then it says list one.
Sigma. It says sigma x. Somebody was asking me about this earlier. It says sigma x because if I did 2 var stats, it would give me a sigma. L1 is a sigma x, and L2 would be sigma y. That's how it just tells me which is which. So the little x doesn't mean shit right now. Later I'm going to come back to it. We'll see.
If you put like 2 data sets.
2.280, right?
Two, you could also connect
You with me?
it.
Yeah.
So I understand some of you guys are gonna be like, well, if I can just do that, why do I have to do the chart? Because I want you doing some work, right? Or else your calculator passes, has a great life.
Wait, what's the list?
Because there's just for one, but
What do you
there's a
mean?
way to connect both of them.
No frequency.
So connect both, like
Yeah.
if there's 2
Just
data
leave it blank and hit
Yes, let's say
calculate.
for instance you have 2 groups, right?
So frequency list is if I put in like a relative frequency, like a percentages.
I
We don't
already
have that for
On my
this.
list,
Yeah.
I already have, let's say,
Second thing I want to show you,
Right.
look at the bottom.
so let's say I have this 2.
Min Q1, so if you scroll down, that's where the 5-number summary is.
Oh, 3.
Mm-hmm. And then you can plug in.
And see what
You
it
would
says
just put
instead of
like a- I
Q2?
think it's comma.
Median, good. So Q2 is
Yeah,
also known as
comma
median,
S,
blah, blah,
and then you
blah,
would
right?
put
So if you
L1.
have to do a box plot problem, you can check your work there.
Or maybe. I
This is
think I
not
can
doing
check.
your work. This is checking your work.
But,
Yeah.
and then you would. There's a way to like separate it, and then you would type in like let's say the
There's no
second
frequency list for this
L2.
problem.
Oh,
If
there
I
you
had a
go.
problem
So
where,
then, in that case,
so later this semester we'll see a problem,
Is
guys.
that what you mean?
Let's
Yeah,
say I
so
had
you can-
20% of
you can
people
make
said
both,
1
then
and
you can see
30% of
the,
people said
the
2.
data for both sets too.
You with me?
Yes.
So I'd have 1, 2, 3, 4 in list 1, and then 20%,
That's what I
30% in list 2. That would be my
I read
frequency
this a long
list.
time ago.
So I have to tell it L2 is my frequency list. We didn't have a frequency list for this problem, right? So we just leave that blank. Okay. Let's see. I do want to point out, look here. S is the standard deviation for a sample. It is obviously different, correct? Why does the calculator give us both? Because the calculator is dumb. It has no idea if the numbers we put in is a population or a sample. We're the humans, we have to pick the right one. Later this semester, you'll wish you had sigma, so when you see that, you're like, oh, I got sigma. But if it's a sample you're working with, no, you'd have to use S. Calculator doesn't know, it just gives you both. It's like, you're a human, you pick, right? Okay, I like it. Why is the sample standard deviation different? We'll talk about it next time. I got through everything I got through in my other stats class, so let's just have an early night. Is anybody upset about that?
No.
I had somebody get angry at me once. You're not giving me my one-each work. I was like, damn.
I had a question about the homework. Can I
Yes.
ask that now?
Yes.
So,